Imagine standing on a wooden deck in the middle of a vast, featureless ocean with no horizon and no compass. You have no satellites, no GPS, and no metal instruments, yet you are tasked with finding a tiny cluster of islands 3,000 miles away. This wasn't a nightmare for ancient voyagers, it was a Tuesday. For thousands of years, humans traversed the Pacific, the Atlantic, and the Indian Oceans using nothing but the organic computer between their ears. Today, we rely on satellites orbiting the Earth to tell us exactly where we are, accurate to within a few meters. But ancient navigators were doing this in 1500 BC, using tools that were entirely invisible to the naked eye. The secret wasn't a piece of technology, it was an intimate, obsessive relationship with the natural world. Take the Polynesian navigators. They mastered the art of wayfinding, a system that treated the entire ocean as a giant readable map. They didn't think about coordinates or degrees. Instead, they used a technique called dead reckoning. They held a steady course relative to the stars, the sun, and the swell of the waves. Think of the stars as a celestial clock and compass combined. Ancient sailors memorized the rising and setting points of hundreds of stars. They knew that if the star Arcturus rose directly over a specific point on the horizon, that was the heading for Hawaii. As the night progressed, stars would wheel across the sky, but their rising and setting points remained constant. By keeping their boat aligned with these star paths, they could maintain a straight line for weeks on end. But what happens when the sky clouds over for days at a time? This is where their mastery of the ocean became truly supernatural. Navigators could feel the waves. In the open ocean, waves are generated by winds that have blown for thousands of miles. These swells are consistent, even if a storm blows in from the side and creates choppy, messy surface water. The deep sea swell underneath continues to roll in a steady direction. A master navigator would lie down in the hull of the boat, feeling the rhythm of the ship. They could distinguish between the primary swell and secondary reflections bouncing off distant islands. It was like reading Braille on the ocean. Then there were the biological signals. Birds were the ultimate scouts. Land-based birds like the white tern or the frigate bird have specific daily routines. They fly out to sea to hunt fish in the morning and return to land to roost at night. By tracking the flight path of a single bird at dusk, a navigator could point their boat in the direction the bird was heading and be virtually guaranteed to find land. They also watched the clouds. Even if an island was below the horizon, the reflection of a lagoon could paint a subtle, greenish tint on the underside of a cloud. They noticed the way the color of the water changed, or the way the debris, like driftwood or specific types of seaweed, drifted in currents that indicated proximity to a reef. This was not a skill passed down through books. It was a mental library encoded through chanting and mnemonic devices. Young navigators in the Marshall Islands used stick charts to learn the theory. These were grids made of palm strips and cowrie shells. The shells represented islands, and the curved sticks represented the patterns of the waves and how they bent around land masses. They didn't take these charts on the voyage. They used them to memorize the feel of the water currents before they ever left the beach. Now, contrast this with the European tradition. We often think of the Age of Discovery as the dawn of navigation, but when the Portuguese reached the Indian Ocean in the late 1400s, they found that local traders were already crossing the Arabian Sea using sophisticated celestial tables and wind charts. The Europeans were the ones who were lost. They were literally discovering places where thousands of people had been living for centuries. The true genius wasn't just the technique, it was the bravery. These voyagers were setting out into the blue void with the confidence that the Earth would provide everything they needed to find their way home. They weren't fighting the ocean, they were listening to it. So, how did they pull it off without crashing? They didn't fear the void. They turned the void into a language. When you strip away our modern dependence on glowing screens and automated signals, you realize that humans have always been incredibly capable of reading the environment. We spent 99% of our history navigating the world through observation, pattern recognition, and gut instinct. We have traded our ability to read the sky and the sea for the convenience of a blue dot on a digital map. We've become masters of information, but perhaps we've become less proficient at being human. We now trust the machine to tell us where we are, but the machine doesn't know where it's going. It only knows what it has been programmed to calculate. The ancient navigators were never lost because they were always exactly where they were, part of the rhythm of the Earth. They understood the ocean not as a barrier but as a highway. They proved that the only thing you truly need to navigate the world is the ability to pay attention. As we look toward a future of increasingly automated technology, it is worth asking, if the satellites went dark tomorrow, would we still know which way is home? Or have we forgotten how to read the language of the stars? Consider the Vikings, sailing not through gentle trade winds but across the cold, gray chaos of the North Atlantic. They had one crucial advantage the Polynesians didn't: a mostly cloud-free strip of sky at dawn and dusk, and a trick that historians debated for over a century. Norse sagas mention a sunstone, a solarsten, used to find the the sun's position even through thick cloud cover. For decades this sounded like myth. Then researchers identified Iceland's spar, a form of calcite, as the likely candidate. This crystal splits light and, through a property called polarization, can reveal the sun's location in the sky even when it's hidden behind clouds or has dipped just below the horizon. A navigator would rotate the crystal until two shadows matched in intensity, and that alignment pointed toward the sun. It wasn't guesswork, it was applied optics, discovered by people who had never heard the word polarization. The Vikings also practiced something called latitude sailing. Rather than plotting a precise course toward a destination, they would sail north or south until they reached the correct latitude, judged by the height of the sun or the North Star above the horizon, and then simply hold that line due east or west until land appeared. It was crude by modern standards, but remarkably effective, and it's how they reliably found Iceland, then Greenland, then the coast of North America, centuries before Columbus. Across the Indian Ocean, Arab and Gujarati navigators were solving a different puzzle entirely: the monsoon. They realized that the winds reversed direction with the seasons, blowing steadily one way for months and then flipping to blow the opposite way. Sailors didn't fight this pattern. They scheduled entire trading seasons around it, riding the wind out to India or East Africa and waiting for the reversal to carry them home. To measure their position, they used a device called the kamal, a simple rectangular card on a knotted string. By holding it at arm's length and lining up the top edge with a known star while the bottom edge touched the horizon, a navigator could measure the star's altitude and from that estimate their latitude with real precision. It's essentially the same principle later refined into the European astrolabe and sextant, except the kamal came first, and it worked with nothing but wood, string, and memory. In Micronesia, navigators developed an entirely different mental framework called etic. Rather than picturing themselves as moving across a fixed ocean, they imagined their canoe as stationary while an unseen reference island moved backward beneath the stars. As specific stars rose and set relative to that imaginary island, the navigator could track progress not in miles, but in conceptual stages, essentially running a form of dead reckoning entirely inside their head, with no chart, no instrument, nothing but a rigorously memorized star compass dividing the horizon into up to 32 points. What ties all of these traditions together is that none of them were improvisation. They were rigorous, teachable systems, refined and tested across countless voyages, then passed down through years of formal apprenticeship. A Micronesian or Polynesian master navigator might spend a decade training before being trusted with an ocean crossing, memorizing star compasses, wave patterns, and bird behavior with the same discipline a modern pilot brings to instrument training. For a long time, much of this knowledge nearly vanished. Colonization, missionary suppression, and the arrival of Western instruments broke the chain of apprenticeship in many Pacific communities. By the mid-20th century, some anthropologists assumed traditional wayfinding was essentially extinct, a relic that could no longer be practiced at sea, only reconstructed in theory. Then, in 1976, a double-hulled canoe called the Hokula sailed from Hawaii to Tahiti, roughly 2,500 miles, guided entirely by a single man using none of the instruments sitting unused in the hold. His name was Mau Piailug, a master navigator from the tiny island of Satawal in Micronesia, one of the last people alive still trained in the old system. He read the stars, the swells, and the birds, and he brought the canoe home. That voyage didn't just prove the old methods still worked. It sparked a revival, training a new generation of Hawaiian navigators and re-establishing wayfinding as a living practice tradition rather than a historical footnote. Which brings the story full circle. This knowledge wasn't lost because it stopped working. It was lost because we stopped needing it, and it survived only because a handful of people refused to let it disappear along with the last of the elders who still carried it.